Good afternoon, good evening to everyone. Welcome to today's online tutorial in statistics and slash decision making techniques. So our focus for today is basically coming from the aspect of probability, where we have to understand what probability is. I believe in previous lectures we've talked about what probability is. We've talked about some of the terminologies involved under probability, and we've looked at information such as some of the counting rules and the counting techniques in probability, and also the methods of assigning probability, where you are supposed to be able to look at the classical approach, subjective approach, and the relative approach, of which we simply mentioned last time that there are only three categories or maybe three classes of how we're able to assign these probabilities. So today our emphasis will be basically just on some of the probability rules we are supposed to be able to take note of. So some under probability we'll be looking at basic rules. So I understand, I'm sure we've come across a number of rules under probability. So we want to just emphasize on them, on how we're supposed to embrace each rule and when can we embrace such rule. So these are the basic rules. So this video is only trying to briefly explain some of the basic rules in probability with relationship to statistics. So number one, I want us to recall something here. That's the definition of probability. I want us to recall the definition of probability, where we simply say that probability is just the chance or the likelihood. Probability is the likelihood of an event happening. So it means that if you look at this topic or this probability in nature, we're talking about various events happening. What is the chance that event 1 can take place, or what is the chance that event 2 can take place, and so forth. So the likelihood or the chance of an event happening in this case is basically the probability which we're talking about. It's probability. And then we simply said last time to say, if you're looking at the probability or the chance of an event A happening, this is just basically the favorable outcomes over the total number of outcomes. That's what we mentioned last time, where if you are looking at probability, remember we are being taught to say probability just emphasizes on the, or maybe we're talking about emphasizing on the likelihood or the chance, the measure. This is more like the measure. If you're trying to assign a probability to a certain event, you're simply saying that what value or what is the chance or what is the percentage that that event A can occur. So you're supposed to be able to look at the number of favorable outcomes in that event over the total number of outcomes. In this case, we're now trying to refer to the sample space and events. I'm sure you can recall in previous lectures when we defined this kind of events. What did we define? What did we say about an event? An event, we just simply mentioned that this is basically just a subset of a sample space. So the event, we simply say that is a subset of a sample space. So the sample space is more like regarded to be the population, and the event is more like to be regarded to more like a sample. So out of all the sample space, we are trying to sample out certain subset from the total outcomes. So if you're looking at the event A, what is the favorable outcomes in the sample space over the total number of outcomes? So if an event is basically just a subset of a sample space, then the sample space is just what? It's just a set of all possible outcomes. So a set of all possible outcomes. All the outcomes are collected in a set S, which is going to be made as the sample space. And then in the sample space, we can come up with an event. For example, if S of maybe the sample space of toasting a coin. What is the sample space of toasting a coin? A coin has only two outcomes. There can be a possibility of me having a head, or there can be a possibility of me having a tail. So basically, what am I simply saying in this case? The total outcome, the total possible outcomes collected will be put in a set called the sample space S, having all heads and all tails. So basically, if I'm looking at the event, or maybe what is the probability that I can have an H happening, that is a certain event, to say the event can be, or maybe the event that a head will appear. So E will just be a set of H. This is an event. Or maybe the event that a tail will appear. E will just basically be equal to the tail, T itself. So now I'm simply saying that the event is basically a subset of a sample space. The event is basically a subset of a sample space. E, which is just having the elementary event H, is contained in the sample space. So E is a subset of the sample space. That's what we mentioned under probability last time. So now from there, we even looked at types of events, where you're supposed to know when events are independent, when events are compound, when an event is simple, compound, mutually exclusive, and so forth. So now, that's why we'll be drawing our basic rules from, based on independent events, based on mutually exclusive events, and so forth. That's why these basic rules will be derived from. So from there now, we'll look at the types of events. We've understood that an event is a subset of a sample space. Now we have to understand that these events can be in various forms, that we said in the previous lecture, but I'm talking about three kinds of events I'm going to focus on today, which is number one, we have to understand what an independent event are. What independent events are. So what are independent events? So when it comes to the concept of independent events, we're just talking about these are events where the occurrence of event does not affect the other. So this one, we're just talking about events where the occurrence, depending on where you come from, the occurrence of an event does not affect the other. So if the occurrence of one event does not affect the other, basically we're simply saying that those events are basically independent. For example, if you are trying to flip a coin twice, so you're trying to flip a coin twice, flipping, how do you spell flipping? I don't know. Flipping a coin twice. So you can flip a coin for the first time. You can both having the head or tail, both of them have equal chances. There is no in a certain way whereby H will interfere the occurrence of having a tail, or tail will interfere in the event of us having a head. So I flip the coin for the first time, I flip for a coin for the second time. All the occurrence here will be basically the same. There will be no interference. So in this case, we're simply saying that the chance of me having the head in the second toasting is still equal to that chance of me having the tail in the second tossing. So both of these, the head and the tail, they both have the same chances. They do not interfere with the other. But when you look at the other type of events, which we are going to be the dependent events, so these ones basically are simply saying that there must be some interference. There must be some interference where the outcome of one interferes with the other. So we're simply saying that this is an event where the outcome of one event affects the outcome of another event. So what do I mean in this case? For example, we're talking about you drawing, we're talking about cards. I'm sure those people who have played cards before will be able to understand the several cards. For example, if I was to select a certain red card from the total number of cards, you will discover that if I select this, I don't know, I believe there are about, is it 52 cards? Yeah. So if you select one card, which is maybe let's say a red card, is being selected from in the first collection, the first selection, a red card was picked without replacement. Without replacement. So the probability in this case of another event is being interfered, whereby we're simply saying that the red card was picked in the first place, but it wasn't replaced in the second picking. It means that the probability in this case have changed. So if the probability of picking a red card was basically 4/52, it means that in the second picking we are going to have 3/51, because one card was picked in the first place and not replaced. So such events are being simply talked about, or maybe being simply referred to be dependent events, where the outcome of one event affects the outcome of another event. The picking of the red card in the first collection has affected probabilities of us picking several cards in the second collection, because the first card was not replaced. So that's the second type of event you're supposed to be able to understand there, where you're talking about dependent event. The outcome of one event affects the outcome of another event. Now we have the third kind of event which you're supposed to be able to understand, which is called the mutually exclusive events. The mutually exclusive events. What kind of events are mutually exclusive? We're simply saying these are kind of events which cannot happen at the same time. We're talking about events that cannot happen at the same time. So if an event cannot happen, we're talking about events which cannot happen for the second time, what kind of an example can I give? E.g., if you flip a coin, there's only one chance you can have, the possibility of us getting a head or us getting a tail. You can't get a head and a tail at the same time when you flip that coin. So what are we simply saying? That in this case, H and T are mutually exclusive because they cannot happen at the same time. H and T are mutually exclusive because they can't happen at the same time. Because if I was to flip this coin at the same time at once, the only probability I'm supposed to have is either the coin can turn to a head or the coin can turn to a tail. So that's what we mean by mutually exclusive events. For example, another example I can give is if you were to roll a die. Rolling a die has about 6 sides. So there's a side where you can either pick 1, you can either pick 2, 3, 4, 5, or 6. So these are 6 faces on a die. So if you are to roll it, there can never be a chance at the same time you have 2 answers which can be formed, 2 and 3 being picked. That can't happen. So what are we trying to conclude on a die? The event of us picking a 1, 2, 3, 4, 5, 6, all these events are mutually exclusive, meaning they can never happen at the same time. They always have different times they can happen. So maybe in this case I need to have about maybe 3 experiments, or maybe I need to have about 2 experiments and the like for me to have different events happening. So in the first experiment I can maybe pick 1, in the second experiment I can maybe pick 2, but otherwise having the same experiment, we are being told that these events cannot happen at the same time. They are mutually exclusive events. So these are the 3 events we're supposed to be able to pay particular attention to, even as we'll be looking at the basic rules in probability.